In this video I'm going to show you how you can protect your server from bots with a CAPTCHA that is shown to players when they join the server. As you can see, when you join the server, you can't do or see anything. You cannot type in chat and you cannot see messages sent by other players, and you get prompted here in chat to click to verify. And as you can see, this is a link to my website and it includes a unique token to identify the verification request. You can set the plugin up to use your own website, of course, but if you don't have a website or simply don't want to put in the extra time of setting it up, you can just get the plugin from Build by Bit and use my CAPTCHA service and website. You can get the plugin with a one-time payment, which is only $2.50 at the moment, and I will run the website and the server as long as I can pay for it. Now when you click the link, you get redirected to the website, which asks you to complete a CAPTCHA. This is just a normal CAPTCHA that you see on the internet, so complete it, then click verify, and you can see the CAPTCHA was successful, and now you can go back to the server and you can play as normal. If you don't complete the CAPTCHA within 2 minutes of joining, you will get kicked from the server and have to try again next time when you join. And this is how the process looks like in a flow diagram. First, the player joins the server, then the server makes a request to the backend to get a CAPTCHA URL that the player can click. Then if the player completes the CAPTCHA, the server checks the backend for the verification status, and if it is successful, it lets the player join the server and play on the server normally. We're going to use a client-server approach with the REST API in the backend. We will do the front end with plain HTML, so no framework like Angular or React. And the first thing you need to do is to create a CAPTCHA project with Google. So go to google.com/recaptcha/admin/create. Then give your project a name, for example, CAPTCHA YouTube. For the reCAPTCHA type, we're going to use challenge v2. This means that the users will be prompted with a challenge that they need to complete. Then for the domains, we need to enter all the domains that we want to allow to display our CAPTCHA. At the moment, we only want to allow local domains, so localhost. And for some reason, you need to also add localhost with an uppercase L. And also 127.0.0.1, then click submit. Then on here you can see that your CAPTCHA project has been created. You get up to 10,000 assessments a month. Down here you see your side key and your secret key. The side key is the key that we will later embed in our website, so it can be public, and the secret key needs to be private. We use this to verify the CAPTCHA requests with Google. And since this project contains web elements, we're not going to use IntelliJ as usual, but I'm going to use VS Codium. You could also use VS Code. VS Codium is just a debloated version without the Microsoft telemetry, but it works exactly the same as VS Code. So open that, then click on File and Open Folder to open the project folder. In my case, I've already created it. Select folder, and inside this project we will have 3 sub-projects, and each of one will have their own subfolder. The first sub-project will be the front end. This is the website that the user sees with the CAPTCHA. Then the next sub-project will be the backend. This is where we send the CAPTCHA requests to Google so that it can verify the request. And the third project will be our plugin project. We will start with the front end, and as in every web project, we need to create an index file. So right click on the front end, a new file, and call it index.html. If you're using VS Codium or VS Code, you can actually install an extension, Live Server, that lets you preview the web page. You need to right click and then open with Live Server, or in my case it says open with 5 server, and then the web page automatically opens in the browser. To create the basic HTML body, just type an exclamation point and press tab, and then inside the title you can give your page a title that will show up here, CAPTCHA, and you can see it updated right here. And then to add the actual CAPTCHA, we can go to Google's documentation, click here, and then here you can see to add the CAPTCHA logic, we first need to add an external script to our web page. So copy that line and paste it below your title, and then copy this div container to display the CAPTCHA and paste it inside the body tag. Then if you go back to your web page, you see that the CAPTCHA works, but we have an error message, invalid side key. And this is because we didn't enter our side key here. We can get the side key from the page and copy it and paste it. And now the captcha should work. I personally like dark mode better, so I'm going to add an extra attribute here, data theme, and I set it to dark. You can see the captcha is now in dark mode. And now let's style the page a bit, make it look better. I want to add a title, center the title and the captcha, and make the background dark as well. And to do that we need to use CSS. So first we need to create a link to our CSS file in VS Codium or VS Code. You can do that with a shortcut. Just type link:CSS and press tab. And this links to our style sheet, which is called style.css. Now we need to create it in the frontend folder, your file, style.css. And inside here we can write our CSS. And then inside the body we're going to create a new div container where we will put the captcha along with some text. You can do that with a shortcut as well. I want the container to have a name of centered container. So just type dot and then centered container and press tab. Now you can get the captcha and paste it inside the container. And I will also add some text. So h1, verify you are a human. You can see there it is. And then in the style.css, we're going to access the centered container div element. Make sure you don't forget the dot in front. And then we do text align center to center the text. We're going to do position absolute so that we can style it like this, 50% from the top and 50% from the left to center it. And as you can see, by default, HTML elements are centered by the top left corner, and we can fix that by using transform, translate -50% and -50%. This means the container will be shifted by -50% of the width to the left and by -50% of the height to the top, and that centers it. Now I also want to change the font that I'm using because I don't like the default one, and we do that in the HTML and body tags with font family, and I like this font. And this looks much better, but you can see the captcha is not centered yet, so we need to do that manually. Go back to the HTML file, and here you can see that the captcha has a class which we can use in the CSS. Copy the name and then here type dot, paste the class name, and if we give it a background color, you can see that the captcha container is bigger than the actual captcha itself, and this prevents the captcha from being centered because it centers the whole container, not just the captcha. And to fix that, you can just say the width of the container should be fit content. This removes that, and now we can center it with margin 0 auto. Now we can remove the background color, and the captcha is perfectly centered now. And now we can make our white background darker as well. I found a color that I like, which is this RGB 36, 36, 36. I like this color because it matches the captcha color pretty well. But now you can see we need to change the text to some other color, for example white, and you do that with color white. Now we can go back to the HTML file, and now we can start defining the logic. At the bottom of the div container, create a script tag, and inside here we're going to put our JavaScript logic. We will define a method that is called when the captcha was successful. In JavaScript you do that with function and then the name, for example success, and then you can create the method body. And now we can link this success method to be called when the captcha was successful with another data attribute. So go back to the captcha element and type data callback, and this is equal to the method that we created here. I call the method success, so the value of this data attribute will be success. And now to demonstrate that this method is called when the captcha was successful, I can print something here, console log success method works. To see the output of this, we need to open the developer tools. In Chrome you can do that by pressing F12 and then go to console. Now let's try the captcha, verify, and you can see success method works. The captcha actually returns a response from Google as well, and we can access that by modifying our success method by accepting a parameter. You can call it response, for example, and then we can just print it with console.log response and then try again. And you can see this is the response that we get from Google, and we can use this response in combination with our secret key to verify that the captcha request by the player was successful. But since we don't want to share our secret key, we're not going to do this in the front end, because everyone who accesses this site can just go to Elements and view the page code, and we don't want to share our secret key. Instead of doing the verification process in the front end, we're going to do that in the backend here, which is private and where users don't have access to. And now we need a new terminal to prepare our backend project. First, navigate to the backend directory with cd backend. This needs to be the name of the backend directory. Then press enter. And since we're going to use JavaScript with Express to create our backend, you need Node installed. If you do not have Node installed, go to nodejs.org and just install Node. You can check if Node is installed by typing node-v. If this doesn't work, even after you installed Node, you probably need to restart your editor. Now, while being in the backend and having Node installed, we're going to initialize our Node project with npm init-y. Then you can see in the backend we have a new file, package.json, with some information. The name is backend, version, the main file, which we haven't created yet, and then some other stuff. And because we want to use modern JavaScript, we're going to add a line, type, and as you can see, we have two options available: CommonJS, which is the default value, and module, which is the more modern and recommended way. We're going to use module for that. And now we need to create the main file in the backend. Right click, new file, and index.js. And then inside here we can just print something to see if everything worked. Console.log hello, for example. And you can run this file with Node and then the name of the file. And you can see everything worked. And since we're going to use Express for our backend, we need to install Express in our Node project first. And you do that with npm. npm stands for Node Package Manager, and install, and then the package name. We want to install Express, so we type Express here. Now you can see our package JSON has changed. Inside the dependencies, Express has been added. Close it and delete the line. To start the Express application, you first need to import it. So type import Express from Express, and then you can get an Express instance and save it in a variable called app, and this is equal to Express. And now you can start the app with app.listen, then pass the port. A port that is often used for backend applications is 8080. And then as a second parameter, we need to pass a callback function. In JavaScript, you can type them in similar lambda notation as in Java. So first the parameters, then an arrow, and then the method body. And in this case, this method will be executed when the Express app has successfully started. So to test it, we can log something to the console as well and type, for example, backend has started on port 8080. Then start the file again with node index.js, and you can see backend has started on port 8080. And now we can access that in the browser by typing localhost : and the port that we specified here, so 8080 in my case. And as you can see, everything worked. This looks like an error message, but it is not. It just means that we haven't provided any content for the default path. And for this application, we don't need to do that actually, but just as a demo to see how you can create content for an endpoint, I'm going to show you how it works. In a REST API, there are different kind of HTTP requests. The two important ones that we're going to use for this project are GET requests. Those are the default ones that you do in a browser. This is why you see GET here. This is used if you want to get information from the backend. And the other important one is the POST request. You can't do that with the normal browser as a user. And the POST requests are used if you want to send data to the backend. And as you can see, this complains that we cannot do a GET request on the empty endpoint, on this default endpoint. And in order to allow GET requests on this endpoint, we can call app.get, and again get because we are doing a GET request. Then this takes two parameters. The first one is the path. In this case, it's just an empty path, so slash. And then the second parameter is a callback method, and this is the code that is executed when a user calls this path. It looks like any other callback method. First the parameters and then the body. If you do requests like this, not only for GET but also for post and all the other requests, the parameters are not empty. You have to provide two parameters. The first one in Express is often called rec. This stands for requests and contains all the information about the request that the user makes. And the second one is called res. This stands for response, and this contains all the information that the response to this request will contain. And if we want to display something here, we need to modify the response object. So res, then we need to provide a status code. A status code of 200 often means that everything went well. You probably know status code 404 if something is not found, or 500 if an internal server error occurred. And then the next thing is we need to provide a body. In REST APIs, the body often is in JSON format. So we do .json, and then we can provide a JSON object here. For example, message, and everything went well. Then restart the backend, go to the terminal, press Ctrl+C, and type node index.js again. Now if you reload the web page, you can see that we get our message. You can also enable pretty print here to make it a bit more readable. This is especially helpful if we have longer JSON responses than this. And just as another demonstration, one thing we can do with the rec object is to get query parameters. And in our project, we will use this to map the CAPTCHA requests to a player. So if we go back to the server, you can see that the URL looks something like this. We have our domain, and then a question mark, token equals, and then a value. This is a query parameter, and you can access those with the request object. The query parameters are saved in rec.query, and you can get a query parameter by deconstructing it, for example, like this, and then type the name of the query parameter in the curly braces. So for example, if you want to get the token query parameter, you type token here. Then log it, console.log token, restart the backend, and if we do a request now, you can see that we get undefined because in this request we didn't define a token. And if we define a token now, question mark token equals very secret token, you can see that we get our very secret token. And this is already most of what you need to know to be able to make this project. In total, we will create 3 endpoints like this for our project. The first one will be an endpoint to generate a URL like this. The second one will be an endpoint to verify the CAPTCHA. When a user completes a CAPTCHA, we will get a response object, if you remember this one here, and we use a verify CAPTCHA endpoint, which we will define in the backend here in this file to verify the CAPTCHA, and this endpoint will be called from this method. And the third endpoint will be a check status update. This is the endpoint that the Minecraft server calls to check if the player has been verified or not. So let's start with the get URL endpoint. And when you do a REST endpoint, you always need to think first what kind of HTTP requests it should accept. So in this case, should it be a get endpoint or a post endpoint? Since we want to get a URL with this endpoint, we need to make it a get endpoint again, like this one here. So type app.get, then the endpoint will be, for example, generate URL, and then our callback method again. This will be the setup for any endpoint that we're going to create here. So first, if we want to generate a URL, we need to generate a random token. As you can see, when you join the server and get the URL, it contains a random token. And you can see this is just a UUID, and we can generate UUIDs from the crypto module in JavaScript. So at the very top, type import crypto from crypto, and then inside here we can save the UUID and generate it with crypto.random UUID. And just for testing now, let's return the UUID in the response. So res.status 200 JSON, and create a JSON object token, and it contains a field called token, for example, and it has the value of UUID. Then restart the backend server and now call the generate URL endpoint. And you can see every time that we reload, we get a different UUID. And now we can construct the URL. So create a new variable for that, const URL, and this is equal to whatever your URL is. For testing purposes, we need to enter the URL of our front end, and in this case it is http 127.0.0.1:5500/frontend/index.html. And then we need to append the token with UID. In the response, we can return the token and we can also return the URL now. So comma and URL, and the name of the field is URL and the value is URL. If you do things like that where the field name and value variable name are the same, you can just shorten it by just typing URL in this case. Now let's take a look at it, restart and reload. Enable pretty print, and now you can see we have our randomly generated token and the URL which contains the token. And now we need a way to save the token for later when the player did the captcha. You could either save the token in a database or just locally here in this file. For simplicity reasons, I'm just going to save it in an array right here. So let pending tokens, and this is equal to an empty array. Then inside here we can add the token to the array with pending tokens.push UUID. And now you can see if we copy the URL from here and paste it inside the browser, our page is shown, everything works, but in the index.html we need to also access the token from the URL and save it in a variable here so that we can send it back to the backend when we do the verify request. And we do that in the script tag outside of the success method. First you need to access the parameters from the URL with const params. This is equal to new URL search params, and here we pass window.location.search. And now we can just extract the token parameter and save it into its own variable with const token, and this equals params.get, and then the name of the parameter, which is token in this case. And just for testing purposes, we can log it to the console as well. It's log found token, then open the developer tools with F12 again, and you can see it works. This matches this. And if you think about what we have done now, we have created the URL generator, so the player can hypothetically receive a URL, click it and complete the captcha. And if the player does that, the success method is called, and inside the success method we have access to the token. And now we need to send the token with the captcha response from Google to our backend again, where we do further verification with Google to check if this captcha request was successful. And for that we need to create another endpoint, but this time it will not be a GET request because we don't want to get any data. In fact, we want to send data. We want to send this response and this token to the endpoint instead of app.get, app.post. The parameters are the exact same. So the endpoint name will be verify captcha, and the callback method with the request object and response object. In post requests, the data is mostly sent in the post request body and not as query parameters as here. So to get the token and the response that is in this post request, we do not deconstruct the query field, but the rec.body field. And from that, we're going to destructure the token and the response. And for testing, let's just return this, a message that everything went well, and just console.log the token and the response. And now that this is not a GET request, we cannot just simply test it in the browser, because as I said earlier, the browser only does GET requests. If you try verify captcha, you can see it defaults to a GET request, and because we haven't defined a GET endpoint for verify captcha, we get this message here. So inside the success method, we're going to use the JavaScript fetch API to make a request to our backend verify captcha post endpoint. So inside the success method, type fetch and then the endpoint, in this case HTTP local host, then the port 8080. And the port is 8080 because we specified it here is 8080, and then the endpoint name, which will be verify captcha. And again, this is verify captcha because we want to call this endpoint, and we called it verify captcha. And then as the second parameter, we need to define some options. In curly brackets, we say that the request method will be post. Do that on a new line actually. And the body will be our response object that we got from Google and the token that we extracted from the URL. And we need to convert that into a string with the built-in JavaScript method json.stringify and just paste that here as an argument. And this converts those two objects into a JSON string. And to make the backend correctly interpret that as JSON, we need to add a header to the request. So headers and curly braces, and the header we're going to use is the content type header with a value of application/JSON. And this simply tells the backend that the content of the body is in JSON format. But the backend does not understand JSON format in body by default. We need to explicitly tell it to understand it. And we can do that with here at the top with app.use express.json. And this enables the backend to understand JSON in post bodies. Now, since this returns a promise, as you can see here, we need to call .then and provide a callback to do something. First, we need to pass the request from the body as JSON. So type response res.json, and then in another then block, we can get the data and just print it for now. Console.log data. And just so you understand it a little bit better, what this does now, it sends a post request to this backend endpoint, which we defined here, and it sends as a body the response object, which we got from Google, and the token, which we got from the URL. Then it takes the response that we got from our backend. So this here, we will change that later so it contains useful information, and interprets it as JSON. And then it takes this JSON data and just prints it to the console for now. So let's open our developer tools and try that. Complete the captcha, and now you can see we got the response from Google, this one right here, but we got an error when we tried to access our backend endpoint, and the error is this, that we got blocked by CORS policy. This is just a security measure that blocks requests by default if they are not explicitly allowed. So our backend at the moment just blocks requests from this domain here. And to make this work, we first need to tell the backend that requests from this URL are allowed. And we can do that in the backend server, stop it, and for that we need to install another dependency. So npm install, the dependency is called CORS, C-O-R-S, press enter, import it with import CORS from CORS. And now we need to let our Express app use it with app.use CORS. Now restart the backend server, make sure you don't get any errors like here. And then we can try again. Okay, now we have a different error. You can see the error is 404 not found because the verify captcha endpoint has not been found. And this is just because I made a typo here. So captcha, and then restart the backend and try again. And now you can see we get our response here and no error messages. In the backend, we see the token that we printed here. This is the token and the response that we printed. Okay, so now the communication between the captcha and the backend already works. Now we just need to verify with Google that the captcha request was successful, and we do that inside the verify captcha. And then based on the response we got from Google, we will change the response that the front end receives. So now inside the verify captcha endpoint, we first are going to add some error handling, because it could be possible that the token or the response field are not set in the body, and we want to handle that properly. So now first check if not token or not response. And this just means if either one of those variables are not set, then we're just going to return, and the response will be with a status code of 400 now. This means that there was something wrong with the request. And as the body, we're going to set a message field with the content of invalid request. Now we can remove our debug log here. And now we need to check if the token is actually a valid token in our system. Because as you can see here, where we create the token, we add it to our pending tokens array. And now we can just check if the pending tokens array contains this token right here. So just check if not pending tokens dot includes token. And then we're going to return a response with a status code of 400 again, but this time we will send a message with invalid token. And now if we do that, we should get the message invalid token, because the pending tokens array does not contain token that we entered here, because we restarted the backend server and this cleared the pending tokens array. So let's try it. And now you can see that we get our error code here, 400, that we specified here, and the message invalid token. So this means at this position in our code, we can be sure that token and response are set and that the token is valid. And now we can contact Google to check if the CAPTCHA request with this response was successful or not. So go back to your Google CAPTCHA page, go to the server-side integration documentation, and you can see here that Google itself uses a REST API with a post endpoint, and the endpoint can be reached here. google.com/recaptcha/api/site-verify. And you can see that you need to add a few body parameters. The secret of your CAPTCHA application, which is this key right here. Then the response, which is what the front end got from Google and which is sent over to the verify CAPTCHA endpoint, which is this variable right here. And a remote IP parameter, but we're not going to use it because it is optional. So just like before, we're going to use fetch API to call this endpoint. So copy it from here, and then we need to create our options again. Say method is post. As you can see, the method needs to be post for this endpoint. And then for the body, we need to pass those parameters here. So pass them here. This is a variable that we have not created yet. So let's create it above, const params, and this needs to be in a specific format. So new URL search params, and inside here we're going to pass the response, which is this required field, and then the second field, which will be the secret. So let's copy it from here and paste it here. If you're the only one working on this code and seeing this code, this is totally fine. But if there are multiple people, or if you plan to push this code to GitHub, then this is not a safe way, because everyone can read your private key then. It's a good habit to not hardcode your key here, but to create an environment file for that. This is what we're going to do now. So create a new file in the backend directory, call it .env, and inside here we're going to create a variable, call it secret, and this is equal to our secret key. Then inside the index.js of our backend at the very top, we can extract this secret variable and save it into a variable, which we call secret as well. And you can access that with process.env and then the name of the variable, which is secret in this case. And then you can replace this with secret. And if you decide to push this to GitHub, then make sure that the .env file is contained in your .gitignore file. Now the same thing, because most REST APIs use JSON as a response, we first need to create a then block, and inside of that pass the response as JSON. So res.json, and then inside a second then block, we can get the JSON data and just print it for now. Okay, so now let's test it. So stop the server. Now that we're using a .env file, we cannot start with the same command as before. We need to pass the .env file as an argument with node-env file equals then the name of the file, so .env, and then index.js. Now we need to generate a new URL. Let's do that manually. So localhost 8080/generate URL, copy it and open it. Then let's open the developer tools and complete the CAPTCHA. And now you can see in the front end we got the message everything went well, which comes from here. And in the back end, the response that we got from Google, you can see success true. That means that the CAPTCHA request was successful, and in this case we would allow the player on the server. And now we can cut this line and paste it here, and we can adjust the response. So instead of a message, we want to have success true, and actually let's create a message as well. Successfully verified, for example. We can also create a catch block to catch any errors. Error, and then the code that should be executed. Then res.status. Let's do a status code of 500. And the response will be a JSON object with a message. Something went wrong. and we can console log the error. Or let's actually do console.error. And now this is almost done. We just need to remove the token from our pending tokens array so that token can only be used once to verify. Removing entries from an array in JavaScript is a bit weird. You do it like this. First you access the array, then you do filter, and then inside here you type an expression that excludes the object that you want to remove. So in this case, you say t for every token in the pending tokens array. You want to check if t is not equal to the token, this one that is provided in the request body. And this filters the pending token array so that it only includes tokens that are not this token. And then we need to assign the pending tokens array to this. Now for the third and last endpoint, we need a way to check if the token was successful or not. So for that we're going to create a map that holds information about the token, if it was verified successfully or not. So const verified tokens is equal to a new map. And then inside the verify captcha method in the second then block we do verify tokens.set. Then we're going to set the token, and the verified state will be whatever is returned by data.success. Because as you can see here, this indicates if the captcha request was successful or not. So data.success. And let's actually do some better error handling here. So if data.success, then we're going to return this. And if the request was not successful, we're going to return res.status with the status code of 400 JSON, and then say message, something went wrong. And this is just a little bit more user-friendly. Now we have created a generate URL endpoint where we can generate verify URLs. We have created a verify captcha endpoint. And now the third and last endpoint will be for the plugin on the server to check if the player was successfully verified. And as you might have guessed, this is a get endpoint because we want to get the status of the verification process. So apt get, and you can call that check status, for example. Then create the callback method with the request object and the response object. And the way that it works is the plugin in the background calls this endpoint like this, for example. You can see localhost 8080, then check status. And then as a query parameter, it provides the token of the captcha request that it wants to check the status. So inside here, we need to extract the token like we did here in the demo endpoint. You can just copy that. Then we need to check if the token is actually present in the query parameters with if not token. Then we send the response with the status code of 400 and a JSON object with a message saying invalid token. Then inside here we can just get the verification status from the verified tokens map and save it into a variable. Const verified is equal to verified tokens.get token. And we need to cast that to a boolean. In JavaScript you do that with 2 exclamation points. The first exclamation point just tells to interpret this as a boolean and negate the value. And now, because we need to get the actual value and not the negated value, we add another exclamation point. And then we can send our response with res.status 200 because everything went well. Then JSON, create a JSON object, and just return the status. Status is equal to verified. And this is already it for the backend. And the only thing that's missing now is the plugin on the server. And now that we have finished the website and the backend server, we can continue with the plugin. And we're going to do that in IntelliJ. So open IntelliJ, create a new project. And for the plugin project location, we're going to select the plugin directory that we have created before. I'm going to call it Captcha plugin with Java 21 and Maven build system. Then click create. And now as always, we just need to add our dependencies. So search for PaperMC Maven and copy them from here. And then just to make life a little bit easier, I'm going to also install the Maven jar plugin to automatically move the plugin into the plugin directory of the Minercraft server. So create a build tag, inside that plugins, and then create the plugin tag and type Maven jar plugin, let it autocomplete, then create a configuration section output directory, and inside here we can specify the output path for the plugin jar. In my case, it's located at user.home/server/plugin. And now when we build the plugin jar will automatically be put straight into the plugin directory of the server. Now we can create the plugin.yml, enter our plugin name, capture plugin, the author, a website if you have one, then the version 1.0 and the API version 1.13, and the path to our main class, io, smcode, captcha, plugin. And now we need to create this main class here. Right click, new Java class and paste. Extend Java plugin, create the onEnable method, and then we can create the config.yml. And inside here we're just going to define a few settings. You can add as many settings as you want, of course. So for this tutorial I'm just going to add 2 settings. Can read messages false by default, and what this setting controls is whether unverified players can read chat messages. And then the same for sending chat messages. Can send messages, which is false by default as well, and whether unverified players can send chat messages. Now save the config file, and now we can create our freeze manager to freeze the player when it joins. So create a new class, call it freeze manager, and then inside here we're going to keep track of all the players that are currently frozen in a hash set, and we create a method to freeze players. And all that this method does is it adds the player that has been supplied here as an argument to the frozen set. So this.frozen add player get unique ID. And for unfreezing we just do the inverse operation, so unfreeze player this.frozen remove player get unique ID. And then we also need a method to check if a player is currently frozen or not. So public boolean is frozen player, and this just returns this.frozen contains player get unique ID. And now to actually freeze the player, we're going to go back to our main plugin class, implement listener, make sure to choose the org.bucket one, and then register the listener. So get server, get plugin manager, register events, this and this. Now create the event handler public void on move. And to freeze a player, we need to cancel the player move event. So in here, listen for the player move event, and get the player, event get player. We want to cancel the event if this is frozen method returns true for a player. So in here we need to get a reference for the freeze manager, private final freeze manager, and then inside here assign a value. This freeze manager is new freeze manager, and actually don't make that final. And then inside the event handler we can just cancel the event if this.freeze manager is frozen for the player returns true. But before we can try this, we need to actually freeze the players when they join. So create another event handler for the player join event, big void on join. We're listening for the player join event, and then get the player reference and freeze the player with this freeze manager freeze and pass the player. And now we can go to the server and check it out. So build the plugin by going to the Maven tab over here, lifecycle and package. And because of this plugin here in the pom.xml, the plugin file is automatically being moved to our plugins folder, as you can see here. And now if you join the server, you can see that you cannot move your mouse, you cannot move the player, and you cannot jump. As the next step, we're going to add the blindness effect. So player add potion effect, new potion effect type dot blindness. And then we need to add a few parameters. For the duration, we're going to use potion effect.infinite duration. For the amplifier, we're just going to use 3. And then the other parameters will all be false to hide the potion effect as best as possible. In the demo you saw at the beginning, we also displayed a title to the player, but we're not going to do this in this step, because first we need to generate a URL, and only if this is successful, the generation of the URL, we're going to display the title to the player. And all the requests that we need to access our backend need to be done asynchronously for better performance, and we're going to isolate them in another class called verify manager. And then later on, when we have methods inside here, we're going to call them asynchronously by creating custom bucket runnables. And if you remember, the first step that we need to do is to get a URL from the backend. So for that, we first need to create a custom class that holds URL information and the token of the URL. So create a new class and call it captcha URL. And this can actually be a record. And this record will hold two fields, a string URL and a string token. The advantage of a record is it automatically creates a constructor for us right here. And even though you don't see them, there are also getters for all the fields that we have created here. So inside the verify manager, create a new method that returns an optional captcha URL. And optional just means that this captcha URL could be possibly null, and call that get URL and make sure to import the java.util optional. And now if you go back to your backend project to take a look at the generate URL endpoint, this one here, you can see that the path is /generate URL, and as a response we get the URL and the token. So since this is a HTTP request we are going to do, we need to create an HTTP client in Java. And this can be static, so at the very top here, create a private static final HTTP client, and this is equal to HTTP client dot new HTTP client. Then we can also define a private static final backend URL variable, private backend URL, and this is equal to the string, of course, and this is equal to the base URL of our backend. If you remember, at the moment, this backend can be reached on localhost port 8080. In the future, you might want to deploy that on your web server, like I did with api.verify.smcode.io. This is just this application, a bit modified to use JWT tokens and so on, but the basic stuff is exactly the same as here. And for testing purposes, since this example only runs locally, we're going to set the backend URL to HTTP localhost port 8080. And then inside the getURL method, we're going to define a new variable for the URL that we're going to call in this method. And this is a combination of the backend base URL, so this one right here, and the name of the endpoint. So this is backend URL plus /generate URL. If you have seen my video about the custom skin changer, you will probably recognize this. This is just a common theme to make HTTP requests in Java. So now we need to create an HTTP request object, call it a request, and this is equal to HTTP request dot new builder. And then we're going to define the URL with URI.create, and then inside here we're going to pass the URL. We need to define the request type, so get or post. If you're not sure, you can always go back to your backend project and check what type of HTTP requests this endpoint accepts. You can see here we used app.get, so this generate URL endpoint only accepts get requests, and for example this verify captcha request only accepts post request. Since we are going to talk to the generate URL endpoint in this method, we need to set the request type to get, and then we can build the request. HTTP requests can fail, of course. For example, if the server denies the request or the internet connection is not working at the moment, so we need to add a try catch block. Then inside here we're going to create a new HTTP response. The response type will be a string. We can just call it response, and this is equal to client.send. We're going to use this client here to send this request. So type request, and the response type as we defined here will be a string. So as the second parameter, type body handlers dot offstring. Then we need to add a catch block, more actions, add catch clauses, and now we can just collapse them. And for testing purposes, we can just print the response. So system.out response.body, and you can see the body is of type string, so everything worked. And just for now, we're going to return an empty optional right here. Then make sure inside the main plugin class you create a reference to the verify manager, then assign a value. And just for testing purposes now we're going to call this.verifyManager.getURL like this. We're going to change this in a few minutes to make it more performant, but just for testing purposes now we're going to leave it here. Build the plugin again and then restart the server. Then make sure the backend server is running or otherwise it won't work. So go back to your backend project, open a new terminal, navigate to the backend project and then run the command to start the backend. You can see everything worked. And now if we try to join the server, you can see here we get our response from the backend. We got this token and the URL. And now inside the plugin, we just need to pass this JSON response and extract the URL and display it to the player. But this parsing and sending the URL request takes up a bit of time, so we're not going to do it synchronously on the main thread as we're doing currently, but we are going to do it asynchronously in a custom bucket task. And we will have a custom bucket task for every request that we're going to do. So create a new package, call it tasks, and then inside the task package we're going to create our first task. And I'm going to call it capture URL task. This task will extend bucket runnable and then implement the run method. As parameters we need the player and we need the verify manager, and then just generate the constructor. And now we can remove the get URL call from here, replace it with a call to run our capture URL task with new capture URL task, then pass the parameters, the player and the verify manager, and call run task asynchronously. As a parameter, pass the plugin, which is this because we are in the main plugin class. And then inside the run method, we can call the get URL task, make sure the variable name is correct, and we can create a variable from that. Optional URL, make it final. And then inside here, we need to check if the URL is present. So if optional URL is empty, then we're going to send the player message. For example, player send rich message in red color. Something went wrong, please contact an admin, and return. And now that we are sure that the URL is set, we can extract it to a variable. String URL is equal to optional URL dot get dot URL. And now that we have the URL, we can send the player message. I'm going to do a clickable message like you saw in the demo before. The player sent rich message again. Then click, the action will be open URL. The URL will be URL. Then close the tag and make sure the URL is in single quotes. And then in green color, click here to verify. Then close the green color tag and close the click tag. Now we can also send the title, player show title. We need to pass a title object. You can create it with title.title. This needs two components, as you can see. A component for the big title and a component for the subtitle. We are also going to pass a times object to make the title stay there forever. So for the main title component text, please verify first in red color. Then for the subtitle, click the link in chat to verify, also in red color. Now for the timings, we need to create a new timings object with title.times.times. This expects three duration objects. The first duration will be the fade in time, then the second will be the stay time, and the third will be the fade out time. We want fade in and fade out to take 0 seconds, so duration.0 for fade in and duration.0 for fade out. Then the stay time will just be something very long, so for example duration of days and 99. This means that the stay duration will be 99 days. Now we can go back to the verify manager and continue with that, because at the moment we just print the response to the console but never actually do anything with it. And this response body is in JSON format, so we need a JSON formatter for that. So access it with final JSON object JSON, and this is equal to JSON parser.parseString, and here we just pass response.body. And then we get that as a JSON object. Now we check if the response was successful, and if you remember from before, a response is successful if the error code is 200. So if response.statuscode is equal to 200, this means that the request was successful. Then we construct a new capture URL, call it capture URL. This is equal to new capture URL. Then inside here we need to pass our two objects that we require, the URL and the token. And as you can see, they are saved under the token field and the URL field in the JSON response of our generate URL endpoint. So let's get them from the JSON object. First the URL with json.get URL.get as string, and the same for the token, json.get token.get as string. And now since the method requires an optional as a return type, we need to wrap that in an optional. Return optional.off captcha URL. And now let's go to the server and test it. And as you can see, we now get the blindness effect, the title, and the link to click on. And if you click on the message, you see that the URL is correct as well with our randomly generated token. But before you can click on it, you first need to make sure to start the front end. So go back in here, go to the front end directory and start the index.html. Now if you click yes here, you see that it opens with our randomly generated token and we can do the captcha as before. Now the next thing we need to do is to make the plugin call this check status endpoint to check if the player has completed the captcha. And we can do this with another bucket task that runs, for example, every 5 seconds or every 2 seconds, however you want. And for that, we're going to create a new task in our tasks package. Check captcha complete task, for example. Extend bucket runnable again and implement the run method. We need the player, we need the verification manager, and we need the token. We need the token to check the status because if you go back to our backend project, you see that we expect the token as a query argument here. Create the constructor. And now inside the verify manager, we need to create another method. And this method will return a boolean and we can call it isVerified. It expects a token. And inside here, we're going to create a URL again. And this is a combination of our backend URL and the path of the endpoint. In this case, it's not generate URL, but check status. So /check status. And make sure if you didn't end this backend URL with a slash to add the slash here. And the other way around, if you added the slash here, make sure that you don't have a slash here and here. And now same thing as before, we need to create a new request object, then check the response and pass the response. So let's just copy this and we can remove this because we don't need it. The default return value will be false. And then inside this if block, we're going to pass the response and from that determine if the captcha is complete or not. If you go back here, you can see that we return a field with the name of status, and this has a boolean value that indicates if the captcha has been completed or not. So what we need to do here is just return json.get, then the name of the field, which was status, and then get that as a boolean. Then go back to the check captcha complete task, and inside here we're just going to get the verification status from the verify manager. So final boolean verified is equal to manager is verified and token. And then inside an if statement we can check the player is verified. Then we're going to call a custom event so that the plugin is more compatible with other plugins and other developers can actually perform custom actions when the player is successfully verified. And you can do that with bucket.getPluginManager.call event, and inside here you need to call the event. And the event will be the captcha complete event. It will expect a token and the player. And of course we need to create that event now. So create class in an events package. And since this is in an asynchronous context, we cannot perform certain bucket methods, including the call event method. And as I want to keep this event synchronous, we need to make this a synchronous call with new bucket runnable.run task, then implement the run method here and paste it here. Then inside here, you need to pass an instance of your main plugin. We can do that with captcha plugin get instance, and then we need to create the instance method. Return instance private static captcha plugin instance, and inside the on enable at the very top we are going to assign a value to the instance variable. Instance is equal to this. Add a semicolon, and I'd like to copy that down. And now this is it for the check captcha complete task, so we can close it. And now we focus on the custom captcha complete event. We actually don't want that to be of type event, but of type player event. Then implement the methods. We need the get handler list method. This is just default for any custom event. And we need to also create a public static handler list, get handler list method. Make sure you don't have any typos there. And this just returns a handler list, which we need to create at the very top. Private static final handler list, call it handler list, and this is equal to new handler list. And then just return it here. and return it here. This is something that any custom event in Paper and spigot.mc need. And then inside here, call the super constructor and pass the player. We need to do this because this is a player event. Inside the main plugin class, we can create another event handler and listen for our custom event. So event handler public void on captcha complete. We're going to listen to the captcha complete event, and in here we can just get the player, this is equal to event get player, and now we can unfreeze the player, remove the blindness effect, and clear the title. The first player clear title, player dot remove potion effect type blindness, and then this dot freeze manager dot unfreeze and player. If you want, you can also play a sound. For example, player play sound at the player location, and the sound will be sound dot entity player level up, and then for the loudness and the pitch, just pass default values. Now, one last thing we need to do is to actually call the check captcha complete task, and we do that in the captcha URL task. At the very bottom, we create a new instance of the captcha complete task, then pass the player, the manager, and the token, which we can get from optional URL.get.token. Then we're going to run this asynchronously with run task timer asynchronously. Pass a plugin instance with captcha plugin get instance. The delay should be 0 ticks and it should run every 20 ticks, which is every second. So now when the URL has been generated, we run the check captcha complete task for every 20 ticks, so for every second, to check the backend if the captcha has been completed. And if the captcha has been completed, you can see we call our captcha complete event, and we listen for that in our main class to clear the title, remove the potion effect, and unfreeze the player. Inside the verify manager, make sure to also append the token. We forgot to do that. So at the end of the URL, add question mark token, and this is equal to token. Now let's see how it looks on the server. Let's join. And you can see we cannot move, cannot jump, cannot do anything. Then let's try to verify. Click the link, complete the captcha, and you can see it worked. Now that we verified, we can move, jump, and do everything that we want on the server. Now, one thing that we can do as well to increase security a little bit, we can cancel a few more events when the player is not verified. So go back to the main class, and then, for example, we can cancel the chat event. So event handler, click void on chat, async chat event. Then let's check the value from the config. Let's start with can read chat messages. And if not, get config, get boolean, enter the path. So if this value is false, then we're going to cancel it, set cancelled. If the player is frozen, event get player. And then the same for send messages, so copy the path. If this is true, so if the player can send messages, then we're going to return, because then we don't need to change anything. But if it is false, we want to get all the audiences. So final iterator, audience, iterator, and this is event get event.viewers.iterator, and this contains all the players that can read the message. And as long there is a value inside the iterator, so iterator has next, we're going to get that audience, final audience, and this is equal to iterator.next. Then we check if the audience is an instance of a player, and if that player is frozen, then this is a player that is frozen, and we want to remove it from the message viewers to make the player not receive any chat messages. So iterator.remove. And I just noticed we did that in the wrong order. So the first one needs to be send messages, and the second one needs to be read messages. Now you can see the read messages and the send messages option is false by default. And if we are on the server, we cannot send chat messages as expected. Again, if coding this and setting this up is too much work for you, you can go check out my build by a bit page, and for only $2.50 you can get the plugin, and I will host the website and the API for you.